Hello viewer, welcome to another video. Today's video about exploring the mysteries of the universe, unifying quantum physics and gravity. The reconciliation of gravity with quantum physics is an ongoing effort in theoretical physics known as quantum gravity. Several theories have been proposed, such as string theory and loop quantum gravity, but a consistent and widely accepted theory has not yet been developed. Quantum physics and gravity are two of the most fundamental forces that govern our universe. However, they have yet to be fully reconciled within a single theoretical framework. The quest to reconcile these two forces has led to the development of several theories, such as string theory and loop quantum gravity. Despite ongoing efforts, a consistent and widely accepted theory has not yet been developed. Quantum physics deals with the behavior of particles on a subatomic level, while gravity is the force that governs the motion of celestial bodies. The problem with reconciling these two forces is that they operate on vastly different scales. Quantum physics is based on the principles of uncertainty and probability, while gravity is a deterministic force that can be described by classical physics. One of the main challenges in reconciling quantum physics and gravity is the apparent conflict between the principles of general relativity and quantum mechanics. General relativity describes the behavior of gravity on large scales, while quantum mechanics describes the behavior of particles on a subatomic level. The problem is that the two theories are incompatible and cannot be reconciled within a single framework. One of the most promising theories for reconciling quantum physics and gravity is string theory. String theory proposes that particles are not point-like but are actually one-dimensional objects, called strings. These strings vibrate at different frequencies, giving rise to the different particles and forces that we observe in the universe. String theory also predicts the existence of extra dimensions beyond the three spatial dimensions and one-time dimensions that we experience in our everyday lives. Another theory that has been proposed to reconcile quantum physics and gravity is loop quantum gravity. This theory suggests that the fundamental building blocks of the universe are not strings but tiny loops of quantum gravity. These loops are thought to be the building blocks of space and time, and they can explain the behavior of both quantum physics and gravity. The quest to reconcile quantum physics and gravity is not only important for understanding the behavior of the universe on a fundamental level, but also has practical applications in areas such as cosmology, black holes, and the early universe. Apart from the challenges of reconciling quantum physics and gravity, there is another fundamental question that scientists are trying to answer. Why are there different types of particles? The standard model of particle physics is the current theoretical framework that describes the behavior of these particles in their interactions. According to the standard model, there are two types of particles, quarks and leptons. Quarks are the building blocks of protons and neutrons and are responsible for the strong nuclear force. Leptons, on the other hand, are the building blocks of electrons and other particles that are responsible for the weak nuclear force. The Standard Model also describes the behavior of the particles through the exchange of force-carrying particles, such as the photon and the W and Z bosons. However, the Standard Model is not a complete theory and does not explain some of the phenomena observed in the universe, such as dark matter and dark energy. The search for additional dimensions beyond the three spatial dimensions and the one-time dimensions of our everyday experience is another area of active research. The existence of additional dimensions is a prediction of some theories, such as string theory. However, these dimensions are not directly observable and their existence can only be inferred through their effects on the behavior of particles and forces. Experiments such as the Large Hadron Collider, LHC, at CERN are being used to search for evidence of additional dimensions. The LHC is the largest and most powerful particle accelerator in the world and is capable of producing high-energy collisions that can reveal new particles and forces. The LHC has already made groundbreaking discoveries, such as the Higgs boson, and is expected to reveal new insights into it. In summary, the reconciliation of quantum physics and gravity is an ongoing effort in theoretical physics. Several theories have been proposed, such as string theory and loop quantum gravity, but a consistent and widely accepted theory has not yet been developed. String theory proposes that particles are not point-like but are actually one-dimensional objects, called strings, which vibrate at different frequencies, giving rise to different particles and forces. Loop quantum gravity suggests that the fundamental building blocks of the universe are tiny loops of quantum gravity. Finally, the search for additional dimensions beyond the three spatial dimensions and one-time dimensions is another area of active research. If you enjoy the video, please do like, share and subscribe to our channel.